Aircraft carriers have defined U.S. naval power for decades, with 11 nuclear giants patrolling the globe. Now, China is launching its own generation of floating airbases, from Fujian's electromagnetic catapults to ambitious but untested platforms like the rumored Type 076. Are these true copies, or is something more complex taking shape beneath the steel and flight decks? To answer that, we need to begin with the vocabulary and technology that built the modern carrier era. The term floating airbase covers a spectrum of naval platforms, each with distinct roles and technologies. At one end are aircraft carriers, which themselves divide into CATOBAR and STOBAR types. CATOBAR, which stands for Catapult Assisted Takeoff but Arrested Recovery, uses either steam or electromagnetic catapults to launch fixed-wing aircraft. This is the system found on U.S. Ford-class carriers, and more recently, on China's Fujian. STOBAR, or Short Takeoff but Arrested Recovery, relies on a ski jump ramp and arresting wires, typical of China's Liaoning and Shandong carriers. Expeditionary Sea Bases, or ESB, are another category. These U.S. Navy platforms support helicopters and drones, and they serve as mobile logistics and special operations hubs. They lack the catapults and arresting gear needed for fixed-wing jets. Amphibious assault ships, such as China's Type 075, focus on helicopter operations and can support amphibious landings. Their decks may accommodate short takeoff fighters, but they do not function as full carriers. A final, more speculative label is the Type 076, reported as a hybrid platform that could blend features of amphibious ships and carriers, possibly with catapults for drones or light aircraft. Whether these are true carriers or something new remains under debate. These distinctions will clarify later comparisons of U.S. and Chinese naval air power. The United States Navy operates the world's largest fleet of aircraft carriers, with 11 active ships divided between the Nimitz class and the Ford class. Each vessel is powered by nuclear reactors, allowing for virtually unlimited range and sustained high-speed operations without refueling. This endurance underpins a doctrine built around global power projection, where carrier strike groups can remain on station for months at a time, far from home ports. The Ford class, the newest in the fleet, introduces the electromagnetic aircraft launch system, called EMALS, which replaces older steam catapults. EMALS provides more precise and efficient aircraft launches, supporting a higher tempo of flight operations and enabling the carrier's air wing to generate up to 160 sorties per day under optimal conditions. A typical United States carrier air wing includes over 75 aircraft, ranging from F-35C fighters to E-2D Hawkeye early warning aircraft. These carriers operate at the center of layered strike groups, integrating destroyers, submarines, and logistics ships to protect the fleet and to extend its reach across the world's oceans. China's People's Liberation Army Navy now maintains 3 operational aircraft carriers: Liaoning, Shandong, and the newly commissioned Fujian. Liaoning and Shandong use ski jump ramps, supporting short takeoff fighters, while Fujian stands out as China's first carrier with electromagnetic catapults, bringing it closer in capability to the U.S. Ford class. The Fujian, weighing over 80,000 tons, began sea trials in 2024 and entered service in late 2025. Its air wing is projected to include up to 60 aircraft, with a mix of J-15 fighters, early warning aircraft, and drones. Alongside these carriers, the People's Liberation Army Navy has fielded 3 Type 075 amphibious assault ships designed for helicopter operations and supporting amphibious landings. Beyond these confirmed assets, reports circulate about Type 076, a possible hybrid platform intended for drone and light aircraft operations. These concepts remain unconfirmed, but they hint at ambitions to expand aviation at sea. This inventory underscores China's move toward a more complex, multi-platform naval air force. Electromagnetic catapults have become the centerpiece of modern carrier aviation. On China's Fujian, the launch system draws power from a medium-voltage direct current grid, itself supplied by a network of steam turbines and diesel generators. This architecture allows the catapults to deliver variable amounts of energy, matching the needs of each aircraft, whether a lightweight drone or a fully loaded fighter. By contrast, the United States Ford class uses an alternating current system, but the underlying principle is similar. Precise control over launch force reduces stress on airframes and expands the range of compatible aircraft. The challenge lies in supplying enough power on demand. Nuclear-powered carriers like the Ford have virtually unlimited reserves, supporting high sortie rates without interruption. Conventional carriers such as the Fujian must carefully balance propulsion, hotel loads, and catapult operations, especially during sustained flight cycles. An engineer familiar with electromagnetic launch physics said that the catapult is only as capable as the grid behind it, and that every launch is a test of the ship's entire energy system. For China, integrating this technology on a conventionally powered hull demanded extensive redesign, trading some endurance for the ability to launch heavier, more capable aircraft. The result is a platform where power generation, storage, and delivery dictate not only what can be launched, but how often, and for how long. Sortie generation on a modern carrier or amphibious airbase depends on more than launch systems alone. The flow of aircraft between the hangar, elevators, and flight deck sets a practical ceiling for sustained operations and defines throughput. On the Fujian, 2 large portside elevators move aircraft between the hangar and flight deck, supporting a projected air wing of up to 60 planes. Each elevator cycle takes several minutes, creating natural choke points during high-tempo flight operations. Efficient deck handling, parking, refueling, arming, and clearing space for landings requires tightly choreographed crews and robust logistics. U.S. Ford-class carriers, with 3 wide elevators and a larger hangar, can cycle more aircraft per hour, enabling higher sortie rates. In contrast, the Fujian's conventional power plant means fuel and munition stores must be replenished more often, limiting how long the ship can maintain peak tempo before needing support. Every hour spent on underway replenishment exposes the carrier to risk and interrupts the deck cycle. These logistics realities, not just raw engineering, determine how many aircraft can be launched, recovered, and readied for the next wave. During underway replenishment, a carrier's ability to sustain flight operations is tested in more ways than deck handling or fuel storage. When a conventionally powered ship, like the Fujian, slows to match the pace of an oiler, it becomes a larger, slower target, and its defenses are stretched thin. Anti-ship ballistic missiles, such as the DF-21D and DF-26, both fielded by China, are designed to strike moving vessels within the first and second island chains. These missiles can reach replenishment groups hundreds of miles from shore, exploiting the window when a carrier and its support ships are tethered together at reduced speed. Submarine threats add another layer of risk, as the People's Liberation Army Navy often patrols choke points and logistics routes. The United States Navy doctrine relies on nuclear propulsion to minimize the frequency and duration of these vulnerable moments. But China's carriers must refuel more often, especially during high-tempo operations. Every hour spent connected to a supply ship increases exposure, making logistics not just a matter of efficiency, but of survivability. In a contested sea, the weakest link is often the one that brings the fuel. No matter how advanced a carrier's technology, its true capability depends on the crews who operate it. U.S. Navy pilots and deck teams build experience over decades, cycling through rigorous qualification programs that demand thousands of flight hours and hundreds of complex carrier landings including night operations in the open ocean. In contrast, China's carrier program is just over a decade old. Most People's Liberation Army Navy pilots have logged fewer hours at sea, with limited exposure to blue water or night flight operations. Deck crews are still refining the routines that allow for safe, high-tempo launches and recoveries. The difference is not just in numbers, but in the depth of confidence and skill that comes from repetition under pressure. Mastery at sea is measured in cycles, not just in hardware. Regional tensions in East Asia have made the operational use of floating air bases more than a theoretical exercise. In the South China Sea, China's carriers and amphibious ships can reach contested waters from Hainan within a day, providing air cover for maritime patrols and island outposts. The proximity of these bases allows for short, high-frequency sortie cycles, but also ties operations to shore-based logistics and missile defenses. In a Taiwan contingency, Chinese carriers would likely operate within the first island chain, supporting amphibious landings or enforcing blockades. U.S. carriers positioned in Japan or Guam face longer transit times, 2 to 4 days to reach the strait. They require sustained endurance and layered protection to contest the airspace. These scenarios highlight how geography, logistics, and platform design shape each Navy's readiness for regional missions. Some patterns are clear. Both navies now field flat-deck carriers with electromagnetic catapults. Both invest in multi-role air wings, integrating early warning planes and drones. Yet, key differences remain. U.S. carriers rely on nuclear propulsion for global reach, while China's fleet depends on conventional fuel and regional logistics. The U.S. prioritizes high sortie rates and long deployments. China balances rapid expansion with evolving training and doctrine. As new platforms appear, like China's rumored hybrid drone ships, questions persist. Is this convergence, selective adaptation, or the rise of a distinct model for sea-based air power? The checklist is open. Today, China's floating air bases test the boundary between imitation and innovation, shaped by engineering limits and contested seas. As maritime rivalry sharpens, the real measure is not resemblance. It is readiness. The next move will not be determined by design, but by who adapts fastest. What is your perspective?